Hey, welcome back. Today we're going to be talking about sound. Okay, some properties of sound. Sound waves are longitudinal, which means they're parallel. Um, Vibrations of particles cause sound waves. Sound waves require a medium, which means they're mechanical. And sound waves spread out in all directions away from the source. So sound waves, again, are going to travel in spheres. Um, Longitudinal, remember, that means that they're going to travel parallel. That's the word that we use for. That's the wave and the medium are going to travel parallel to each other. More about the properties of sound waves. The speed of sound depends upon the medium. Again, that medium meaning that they are mechanical waves. Right? Medium, mechanical waves. Sound's going to travel fastest through solids. They used to, when they were going to rob trains, they would listen to iron rails. Why? Because the sound traveled faster through the iron rails than it did in the air. So they would be able to tell that when the train was coming quicker by listening to the rails than they could in the air. It's next going to travel fastest through liquids. This is why whales and sea animals that communicate, can communicate with each other because it travels very quickly. And then the last, slowest way to communicate is the way we as humans communicate, and that's through air. Right? This is the slowest by all means. As you can see here, here's some examples of this. This down here at the bottom, we've got an example of how it traveled through the iron rails. It traveled at 5,000 meters per second. When you compare to what we listen to, all right, how we communicate, we're communicating at 331 meters per second. So you're talking about the iron rail being 12, 13, 14, 15, 16, over 16 times faster than what we do. And then even like sea animals, whales and such, they're speaking or traveling or communicating with each other almost 5 times faster than what we are. Next thing is talk about is loudness. Um, Intensity describes the rate at which a sound wave transmits energy through a given area of a medium. We don't really have units for loudness. What we do is have units for intensity because there's two things you can do to make something louder. First of all, we have the amplitude. You can simply just say something with and raise your voice. Right? You can simply just raise your voice, or the distance. So there's two things that your father could do if he wanted to get your attention. A, he could raise his voice, and that's increasing the amplitude. Right? And this is one of these key words here that you guys are going to have on the test, and we need to make sure that we can explain that very well. We don't want to say my dad just raised his voice. We want to say he raised his amplitude. And then the other thing your father would do, or my father would do at least, was he would get real close to your face. So he's going to decrease the distance to make sure there was no discrepancy in what he had to say. Doing either one of these is going to increase the intensity, or if you do the opposite, it's going to decrease the intensity. But intensity is measured in decibels. Decibels is not telling us how loud something is, it's telling us how intense it is. For example, a jet has a very high decibel reading, but that's only if you're really close. If you're a mile away from the jet, it's not nearly as loud as maybe the radio that's right beside you. All right. Someone whispering may not appear to be very loud to you until they come right up and whisper right in your ear when you're trying to sleep, and then it's considered to be very loud. Here's some readings, real quickly, of decibel readings. A jet engine, if you're fairly close, is 140 decibels. A rocket engine would be 200. Chainsaw is 100. You guys basically in the cafeteria is around 85 decibels. Pitch, a measure of how high or low a sound is perceived to be. High pitch sound, high frequency. low pitch sound, low frequency. And we've discussed that already in class, so I'm not going to go over that a whole lot. Um, but think of some girl in your class who has a very high pitch. Well, she's got a high frequency. Think of one of your dads or uncles or teachers that have a very low voice. They have a very low pitch, or they have a low frequency. A lot of times, middle school girls, when they're laughing, is a very high pitch, high frequency sound. Your uncle, or maybe an older uncle, has a very low pitch sound. Infrasound. Infrasound is lower than 20 hertz. It's lower than human hearing. Um, Ultrasound is something that's ultrasonic. It's higher than 20,000 hertz. It's higher than human hearing. So what this means is, in general, humans can hear from 20 hertz all the way to 20,000 hertz. And that's not exact. Uh, Obviously, some people might hear up to 21,000 hertz. Some people might hear down to 15 hertz. But in general, on average, we as humans can hear in that range. Something added here is whales typically communicate at less than 20 hertz, and dog whistles are more than 20,000 hertz. Musical instruments. Instruments produce sound through the vibration of strings or their air columns or their membranes. Strings from guitars, columns from horns, and then membranes from some type of drum instrument. Instruments use resonance to amplify the sound. What happens is, let's take for example a drum. You've got the membrane, and then you've got the side of it. Well, the side of it is going to vibrate as well, and that's what we call resonance. And what that does is it creates more sound. So that way it's not just the membrane that's vibrating, it's actually the whole instrument that's vibrating. Okay, we're going to talk about more about this in class video, but natural frequencies, the specific frequencies of which object is most likely to vibrate. All instruments have that. And then resonance, a phenomenon that occurs when two objects naturally vibrate at the same frequency. So like an instrument, the membrane, and then the surrounding drum. A guitar, the string, and then the actual part that you're holding on to is resonating. Okay, let's talk about the ear. There's three main parts of the ear. There's the outer ear, the middle ear, and the inner ear. These are the three main regions of your ear. Ultrasounds, sonar, sonograms, these are all reflected sound waves used to determine distances or create images. Ultrasounds used to create an image. Sonar is used to find a distance of how far something is away. And then sonograms is also used to create an image. Ultrasound imaging is used in medicine. These reflected waves can be made into a computer called a sonogram. Sonar, sound navigation and ranging. Sonar is used to locate objects underwater. All right, sonar system determines distance by measuring the time it takes for sound waves to be reflected back from a surface. This works because we know the speed of sound in water is 1,490 meters per second. If they want to find the distance, they simply know that the speed is 1,490. If they've measured the time, right, so they'll have some time it takes to get there, they can find the distance, how far something below them or above them or to the front of them or behind them is. And it's all about knowing the speed or being able to take for granted that the speed of sound is a certain speed in water. Well, hey, I know this has been a little bit longer today, but hopefully you guys have learned some things. I'll catch you guys on the flip side.